Our next statistics topic is probability, and today we're going to look at set notation and Venn diagrams. So you've done this at GCSE, so it shouldn't really be anything new, but it might occur in a slightly more complicated way at A level than it did at GCSE. So let's have a look at the notes. So we know that A intersect B is written like this, with this sort of N shape. And if we're looking at it on a Venn diagram, if this circle represents A and this circle represents B, then the overlap is A intersect B. Remember that if A and B are independent, the probability of A intersect B is the probability of A times probability of B. So remember, independent events don't have any effect on each other. The event A or B can be written using the union symbol. So A union B, and union is like this U shape. So I remember the U as the union, the intersect as being like an N, so like fish and chips, it's A and B, A and B. And the union is OR, so A or B. So if this circle is A and this circle is B, if we want A or B, in maths we would also mean or both. Then that's anything in circle A or anything in circle B. So it would be the entire region within the circles. Remember, if A and B are mutually exclusive, it means they can't happen at the same time. So it would mean that A intersect B doesn't exist. The probability is 0. So the probability of A plus the probability of B would be probability of all of this. This bit would be empty, so A plus B is the same. Sorry, probability of A plus probability of B is the same as the probability of A union B. We've also got the complement notation, which is just a dash, like an apostrophe. So A dash is the complement of A, and that's everything that is not in A. So if this circle represents A complement is everything except for that circle. So that's this only set notation that you need to know. You might need to use them in combination, so you might have something like A complement intersect B, or A union B complement, or you might even have 3 sets involved, so you might have A intersect B union C complement or something like that. Let's have a look at a couple of examples. So our first example is about a card being selected at random from a pack of 52 playing cards. Remember, in your pack of playing cards you have 4 suits. You have diamonds, hearts, spades and clubs, and within each suit you have ace, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen and king. So if we're completing this Venn diagram, I'm just going to put how many will be in each set. So if our first circle represents the set of cards that are aces, and our second circle represents the set of cards that are diamonds, then we have 1 in the intersection, which is the ace of diamonds, and we have 3 other aces, the ace of hearts, the ace of clubs and the ace of spades. We will have 12 other diamonds, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen and king. And then remember that anything within the box but outside of the circles is anything that is not an ace or a diamond. So we've got 16 cards here at the moment out of a pack of 52, so that means we must have 36 cards that are not aces or diamonds. So now we can work out probabilities. So if I want the probability of A intersect D, that's the overlap. So there's 1 card in there out of 52 cards in total. The probability of A union D is anything within a circle. So there's 16 cards there, so that's 16 over 52, which would cancel down to 4 over 13. A complement is anything not in A. It's probably quicker to think that there's 4 here, so there's 48 not in here. So 48 over 52, which would cancel down to 12 over 13. And then A complement and D, well, A complement is anything not in A. D is this bit here. So the only bit that is in D and A complement is this 12. So we have 12 over 52, which cancels down to 3 over 13. Okay, let's have a look at a slightly different example. In this one, we're asked to draw a Venn diagram for ourselves. But first, we've got information about A and B. We've got the probabilities of those. We've got the probability of A intersect B, and we need to explain whether they are independent. Remember, if they are independent, then the probability of A multiplied by the probability of B is the same as the probability of A intersect B. So let's have a go at multiplying the probabilities of A and the probability of B together. So 0.3 times 0.4 is 0.12. That is not the probability of A intersect B, so A and B are not independent. Okay, we now also have information about the event C. We know its probability is 0.2 and that the events A and C are mutually exclusive and that B and C are independent. And we need to draw a Venn diagram. Now usually if I've got 3 events, I would draw a Venn diagram with 3 circles overlapping like this, remembering to put them all within a box. However, in this case, we are told that A and C are mutually exclusive. So anything which has A and C in would be empty. So we don't need this region here. So instead, I could draw 3 circles like this to represent A, B and C. Because I do not need my A and my C to overlap. So let's draw that type of diagram so that we've got a simpler diagram to use. Okay, so let's fill in what we know. We know that A intersect B is 0.25. So this time I'm filling it in with probabilities. I know that the probability of A is 0.3. We've already got 0.25 in the intersection, so the probability that we have A and not B, so just this region here, is 0.05. We know that the probability of C is 0.2 and the events B and C are independent. So that tells me that my probability of B times my probability of C will give me the intersection. So we will have 0.08 in our intersection. Our probability of B is 0.4, so we've got 0.25, 0.08, that leaves us with 0.07 in the bit that's in B but not in A or C. And then finally here we need 0.2 for our probability of C. We've got 0.08 in the intersection, so this must be 0.12. And then don't forget to fill in anything outside of the circles. So if I quickly add up, I've got 0.05, 0.25, 0.07, 0.08 and 0.12. That adds up to 0.57. So I must have 0.43 outside of the circles. So there's my Venn diagram completed. It now has all probabilities adding up to 1. So for part C, I want the probability of A intersect B complement. So that means it needs to be A and not in B. So here's my circle A, and the bit that is also not in B is this 0.05. And I need that or something that's in C or something that's in both. Well, we don't have anything that's in both, but we do have all of this in C. So the yellow region is in A intersect B complement or C. So our probability is 0.05 plus 0.08 plus 0.12, which gives us 0.25.